Hello everyone, welcome back to our channel. In this video, we'll demystify the buzzword AI agents and we'll explain the difference between large language models, LLMs, AI agents, and agentic AI agents. Moreover, we'll cover the trends and impact of this rapidly developing technology on the workforce, productivity, and overall economic impact on the society. Just a couple of decades ago, artificial intelligence was barely scratching the surface of natural language processing, natural language understanding, and the beginnings of computer vision. The transformer and large language model era revolutionized natural language processing when parallel processing and self-attention mechanisms were introduced by the transformer architecture. This was followed by instruction tuning and alignment. Models began being fine-tuned on instruction-following datasets. In 2022 and 2023, we saw emergence of ChatGPT, which marked shift toward conversational AI, and LLMs started answering complex questions, marking the advent of modern AI. 2024 was the year of AI agents, where an AI actually completes a task. You ask it to do something, and it performs the task and tells you how to do it. AI agents were able to actually outperform some of the best cybersecurity penetration testers in the world. These AI agents designed for cybersecurity roles were able to attack websites with the permission of the website providers, find vulnerabilities, and report back these vulnerabilities. They completed this entire task in minutes, something that could take days for humans to perform. In 2025, we'll see more such sophisticated AI agents and will hopefully witness the rise of agent-driven business models, both vertical and horizontal agents, and the widespread workplace adoption of AI agents. We'll see shift from tools like Microsoft Copilot to AI agents and get a glimpse of the potential dark side of agents, including cybercrime and military implications. This will amplify the debates and discussions on how the rest of the world is thinking about and viewing AI agents, especially in context of ethical use of this technology, since only a few countries will possess this capability. And beyond that, in 2026, we are likely going to see agentic AI and swarms of AI agents, networks of AI agents all working together and maybe even against each other to achieve desired results. One of the main reasons why people are so excited about AI agents is because of the promise of using artificial intelligence to complete end-to-end tasks. Not every task, but many tasks. LLMs open the doors to the possibilities of automation, but not much value was extracted by people and corporations. With AI agents, people and corporations will start extracting real value and get a handsome return on their investment. AI agents are all set to transform businesses and industries and reshape the way we work and interact with technology. So moving on, let's first explain the difference between large language models, LLMs, AI agents, and agentic AI agents. Let us break this down clearly by explaining each concept with concrete examples. Imagine LLMs as the brain and AI agents as the body. For example, GPT-4o, Claude, Gemini, Llama 3, Mistral, Grok, and more recently, DeepSeek, and all others are more like just brains. GPT-4, for example, is an LLM, where you can ask the AI any normal question, and it will give you a very good answer, an answer way better than what Google search was providing before. It can even give you medical advice or find things for you or research things for you. Think about having Einstein's brain as your assistant. The AI brain will give you all the answers you need, and even compose elegant documents, research papers, and other stuff like that. This is because these brains, or LLMs, are AI systems trained on vast amounts of text, image, video, and programming source code data to understand and generate human language, images, videos, music, and computer code. They excel at tasks like writing, analysis, answering questions, creating images, etc. But they operate within a single conversation turn. They receive input, process it, and provide output. Think of them as very sophisticated text and image processors that don't maintain any state or take actions beyond generating what they are asked to do in the input prompt. Even though large language models are trained on unimaginably vast amounts of data, yet they remain unable to adapt to simple problems they haven't been trained on or make novel inventions no matter how basic. So what's an AI agent? An AI agent combines the brain with a body that can actually take action on the LLM's thinking and its memory, and can do many different tasks, and can actually interact almost like humans do. Of course, AI agents are not embodied in any physical form as yet, and only exist as computer code. As such, they can only perform cognitive tasks and not any physical tasks. Today, almost all AI agents are in a form of software code only, but in future, this will change. In a couple of years, we may have AI agents embodied in a human-like entity capable of doing physical work just as we do. One example of software-only AI agents today is systems that let you work on your computer just as you would. They can operate the keyboard and type things, click on things, and they see what is going on in the computer screen just as you do. They can traverse websites and buy and sell things. They can answer your messages, emails, and organize your documents, etc. They can even do your entire programming and coding if you are into that. Another AI agent example is think of a simple customer service chatbot. It can recognize when a customer asks about store hours, provide the pre-programmed store schedule, transfer to a human agent if it doesn't understand a query, follow a decision tree to handle basic troubleshooting. This chatbot is an AI agent because it responds to inputs and follows defined rules, but it doesn't take initiative or adapt its approach significantly. So basically, AI agents are software programs that can perceive their environment and take actions to achieve specific goals, but they operate within defined parameters and follow predetermined rules or learned patterns. They don't necessarily show initiative or autonomous decision-making beyond their programmed tasks. This simple analogy might explain this further. An LLM is like a very knowledgeable consultant who can give you advice and information, while an AI agent is more like an assistant who can actually go and do things for you, schedule meetings, book travel, or control smart home devices within the parameters that you have defined or allowed. And one of the parameters that you may have restricted is to access your bank account and make payments. That is, only you in person can actually decide how to pay and when to pay. The AI agent can't make that decision. To summarize, AI agents have several distinguishing characteristics. For example, number 1, persistence. Unlike LLMs, AI agents maintain state and memory across multiple interactions, allowing them to learn from past experiences and adapt their behavior. Number 2, action. AI agents can interact with their environment, whether that's accessing external tools, making API calls, or controlling robotic systems. They don't just process text, they can take concrete actions in the real or virtual world. They can even invoke different LLMs or different experts to assist them in accomplishing their goal. Number 3, planning. AI agents can break down complex goals into smaller steps and plan sequences of actions to achieve them. They often use techniques like tree search or hierarchical planning to make decisions. Number 4, agency. This is important. AI agents have some degree of autonomy in deciding what actions to take to achieve their goals. While LLMs respond to prompts, agents actively pursue objectives. It is important to note that AI agents only perform permitted tasks and act within these constraints. Now let's look at Agentic AI agents. Agentic AI agents are the next revolution in AI, and while they do not possess truly human intelligence, like artificial general intelligence or AGI, they are certainly a giant leap in that direction. You can say that Agentic AI agents are the first sparks of AGI. What makes them different than AI agents is that they have autonomous decision-making. If you recall, we gave an example earlier where AI agents can be restricted to perform all the e-commerce transactions, except access your bank accounts to decide how to make the payments and actually perform the task of making payments. They can autonomously decide which form of payment to use, as they will have the ability to think, reason, analyze, and take actions as they see fit. Agentic AI agents demonstrate more autonomous behavior, can take initiative, and make independent decisions about how to achieve their goals. They can adapt their approach based on context and potentially even set their own sub-goals to accomplish a larger objective. We are almost certain that today's AI agents will evolve into agentic AI agents in the coming 2 to 3 years as a prelude to AGI. The term agentic AI is befitting because the next generation of AI agents will be able to take autonomous actions to achieve specific goals. Here is an example of an agentic AI agent at work. Consider an AI personal assistant that manages your calendar. It can proactively suggest rescheduling an outdoor meeting if it detects rain in the forecast. Learn from your behavior that you prefer morning meetings and automatically prioritize morning slots when scheduling. Notice you haven't taken a lunch break and suggest blocking off time. Recognize conflicts between personal and work commitments and propose solutions before you notice them. This agentic AI agent demonstrates agency because it takes initiative without being explicitly prompted, makes autonomous decisions based on context, adapts its behavior based on learning from interactions, sets and pursues its own sub-goals to achieve the main objective of managing your calendar effectively. The key distinction is that agentic AI shows more independence and proactiveness in pursuing goals, while regular AI agents tend to be more reactive and confined to specific programmed responses. Agentic AI is the next step in the evolution of AI. This is bigger than the developments in previous generations and is a giant step towards artificial general intelligence, or AGI, a term used to describe full human capabilities of thinking, reasoning, decision-making, and autonomous agentic behavior. One of the most fascinating aspects of the AI revolution is that artificial intelligence itself is now accelerating research, development, and innovation in the field. As AI systems are fed more data and equipped with improved algorithms and frameworks, their capabilities continue to expand. This rapid technical evolution in architectures and infrastructure is fundamentally shaping the future of AI, with far-reaching implications for geopolitics, economies, and the modern workplace. The pace of change is so unprecedented that even well-funded and mature organizations are struggling to integrate AI into their workforce effectively. Before examining the economic and workplace impacts, let's explore the key technological trends and innovations driving rapid AI adoption and shaping our future. First are innovations in cognitive architectures and development tools. The emergence of new custom cognitive architectures is enabling more capable and potentially safer AI agents. Unlike earlier attempts in 2023 and 2024, such as AutoGPT and Baby AGI, these new architectures incorporate robust guardrails and frameworks for controlled operation. This evolution is supported by dedicated tools for agent development, including new frameworks for back-end development, agent orchestration, and advanced testing capabilities. Next is DeepSeek's revolutionary advances. A Chinese company, DeepSeek, has made several exceptional innovations that have fundamentally altered the landscape of AI investment, model development, and ethics in the AI space. Their breakthrough improvements include architectural improvements in mixture of experts with advanced load balancing for expert specialization, multi-head latent attention, multi-token prediction, FP8, quantization, group relative policy optimization, integration of chain of thought reasoning with reinforcement learning, and model distillation, among a few others. Then we have the rise of multi-agent systems. This is another significant trend where multiple AI agents work together like cross-functional teams. Each agent has specific roles, similar to human job titles, enabling more complex and nuanced task completion. This approach is becoming the norm for enterprises seeking scalable value, as it allows for greater customization and handling of complex tasks. Another technical improvement is multimodal capabilities in LLMs. AI agents are increasingly incorporating multimodal abilities, including the processing of video, audio, images, and computer control. Projects like Google's Astra, Microsoft's Copilot, and OpenAI's Operator demonstrate the potential for agents to have more comprehensive environmental perception, opening new possibilities for both enterprise and accessibility applications. These breakthroughs are encouraging the democratization of AI. While 2023 and 2024 saw remarkable AI systems from the open-source community such as Llama 3.1 and Falcon 180B, Mistral and others, the real breakthrough in AI democratization came from DeepSeek, the Chinese company mentioned earlier. In January 2025, DeepSeek's release of their open-source DeepSeek A1 model triggered an unprecedented disruption in the AI industry, causing the largest single-day market capitalization loss in U.S. history, $2 trillion in U.S. stocks. NVIDIA alone saw its market value decrease by over $500 billion in a single trading session. The catalyst was DeepSeek's achievement in developing a reasoning AI model that rivals OpenAI's best offerings at a fraction of the cost. Their R1 model demonstrates superior performance compared to expensive and proprietary AI solutions from industry giants like Google, OpenAI, NVIDIA, Meta, and Tesla. The economic implications of this are huge. The economics of DeepSeek's achievement are remarkable. For example, base training cost, excluding ablations, smaller runs, and data generation, are reduced to $5.5 million only in GPU hours, and this cost, including reinforcement learning, is approximately $6 million. In comparison, OpenAI's GPT-4 reportedly cost $600 million to train. Moreover, operational costs have dropped to less than $4 per million tokens, compared to OpenAI's $100+ per million tokens. DeepSeek's commitment to transparency and accessibility sets a new standard in the global AI race and has raised the bar for transparency in AI models' internal explainability. Their R1 open-source model features a permissive license and fully disclosed reasoning steps, with public code and comprehensive technical documentation. This disruption has prompted a fundamental re-evaluation of AI development assumptions. The notion that superior AI requires vast GPU resources and enormous electricity consumption is being questioned, while attention turns to China's emerging role in the AI race. The future of AI innovation may lie not in overwhelming resources, but in clever, efficient approaches to model development and training. Experts predict that by 2030, the number of AI agents may exceed the human population. With lower barriers to entry, LLMs and AI agents will become commoditized, following a many cars, fewer engines model. While breakthrough technologies may concentrate among a few labs and providers, applications and implementations will proliferate across industries. Now let's look at the economic impact of AI agents' trend on the workplace. As artificial intelligence continues its rapid evolution, 2025 marks a transformative period in enterprise AI adoption. Organizations across industries are facing the paramount challenge of integrating AI into their modern workforce. This year represents more than a technological trend. It signifies a fundamental shift in business operations, with nearly every commercial organization either launching agent-based offerings or incorporating AI agents into their existing processes. The market for AI agents is divided into two main categories: horizontal and vertical platforms. Horizontal platforms provide the foundation for building agents across diverse use cases without specialization. Notable examples include Microsoft's Copilot and OpenAI's upcoming Operator platform. These solutions serve as entry points for organizations beginning their AI integration journey. Vertical platforms focus on specific organizational functions or precise use cases closely aligned with business acumen and industry-specific content. For instance, Sierra specializes in customer support agents, while Devin operates as a sophisticated software engineering assistant. While horizontal platforms will see widespread adoption, vertical agents are projected to deliver superior ROI in 2025, offering organizations enhanced safety measures and industry-specific capabilities. Moreover, the evolution from text-based AI to sophisticated multimodal systems has initiated a new era of true integration between AI and human workers. This transformation is fundamentally restructuring organizations, particularly within Fortune 500 companies. Traditional management paradigms are evolving as leaders prepare to oversee blended teams of human and AI agents. or AI workers. The conventional role of human capital management is expanding to encompass human and machine capital management, focusing on optimizing both human potential and AI capabilities. AI integration spans from personal assistance to complex support functions and background automation. This transition requires new workforce competencies, particularly in AI oversight and management. Organizations are developing frameworks to determine appropriate levels of AI autonomy versus human supervision, ensuring effective collaboration between human and machine colleagues. Advancement of AI agent capabilities throughout 2025 will be a critical turning point in workplace efficiency. Continuous improvements in speed, accuracy, and cost-effectiveness are driven by optimized hardware, enhanced algorithms, and sophisticated learning capabilities. Early adopters will gain significant competitive advantages, achieving 25 to 100 times better results than their competitors. This unprecedented efficiency gain is catalyzing substantial market wealth transfer, though pricing models must evolve beyond traditional SaaS approaches to reflect the true value of AI systems. Several new career opportunities will arise. There will be new career paths, including AI specialists with deep industry expertise, human AI integration experts, corporate AI safety officers, and AI management specialists. The consulting services sector is expanding particularly rapidly, with AI experts and consultants serving as crucial bridges to accelerate enterprise AI adoption and value extraction. Traditional sectors including healthcare, education, and legal services are poised to undergo comprehensive transformation as the combination of improved speed, safety, and cost-effectiveness makes AI agents adoption inevitable. The workplace of tomorrow will feature seamless collaboration between human and AI agents, each maximizing their unique strengths. Success in this transition requires organizations to establish clear operational boundaries, develop new management frameworks, and cultivate an environment where both human and AI capabilities can flourish. This evolution represents not merely a technological advancement, but a fundamental reimagining of work conception, execution, and management in the modern era. This brings us to the challenges that organizations deploying AI agents will face and considerations that must be addressed. Among these, the foremost is security and ethics. The advancement of agent capabilities brings increased concerns about security and ethical implications. Organizations will need to focus on developing agents that are fair, privacy-aware, secure, and protected against biases. The autonomous nature of agents requires deeper consideration of ethical implications than previous AI systems. Safety and governance must be addressed as a priority. For corporations, the runaway nature of AI leaves very little room for failure. AI safety must rapidly ascend corporate priority lists, if it is not already, becoming a board-level concern rather than merely a regulatory compliance issue. The increasing sophistication and autonomy of AI systems leaves no choice but to have a heightened focus on safety. Organizations and individuals must remain cautious about granting AI agents direct access to financial systems at this stage. While there may be experimental use cases with segregated accounts, widespread adoption of autonomous financial operations will likely extend beyond 2025 when agentic AI agents mature. Most likely AI agents will not be trusted with any sort of financial control until the industry has matured with proven checks and balances. Of course, potential misuse is a major concern and will remain as such. As with any powerful technology, there are concerns about potential misuse of AI agents for fraud, cybercrime, and other malicious purposes. The increased autonomy and sophistication of agents will require robust security measures and ongoing vigilance. Looking ahead to 2026 and beyond, the current breakthroughs in large language models, LLMs, and AI agent development are paving the way for autonomous and agentic AI, artificial general intelligence, AGI, and eventually superintelligence, ASI. Innovations such as mixture of experts, chain of thought reasoning, and other advanced technologies are accelerating this trajectory. These developments are not just incremental improvements, but foundational steps toward more sophisticated thinking and reasoning AI systems. One of the most promising near-term advancements is the emergence of AI agent swarms by 2025. These networks of specialized AI systems work collaboratively to solve complex problems and even develop new advanced AI algorithms. By combining diverse capabilities into coordinated systems, AI agent swarms amplify the impact of individual agents, bringing us closer to AGI and ASI much sooner than anticipated. The timeline for achieving breakthrough AI capabilities has shortened dramatically. Many experts predict that agentic AI systems will soon surpass expectations, surprising even the most skeptical observers. This rapid progress underscores the importance of proactive preparation for organizations aiming to stay competitive. The AI workforce revolution represents more than just technological advancement. It is a fundamental reimagining of how work is performed. Organizations that embrace this transformation early will gain significant competitive advantages, while those that delay risk falling behind. The pace of change is unprecedented, making it crucial for organizations to begin preparing now. To thrive in this new era, organizations must focus on the following priorities. Early adoption and experimentation. This means proactively explore and implement AI technologies to understand their potential and limitations. Clear AI integration strategies. Organizations must develop well-defined plans for incorporating AI into workflows and decision-making processes. Investment in human and AI capabilities. Organizations must equip both human employees and AI agents with the skills and tools needed for effective collaboration. And robust safety and governance frameworks must be established with clear guidelines to ensure ethical, safe, and responsible AI deployment. As we move into 2025 and beyond, the question is no longer whether organizations will adopt AI agent workforce solutions, but how quickly and effectively they can integrate these technologies into their operations. Success will depend on creating productive partnerships between human and AI agents while maintaining the agility to adapt to rapidly evolving capabilities. The developments in 2025 will set the stage for even more significant advances in 2026, when enterprises are expected to deploy AI agents as a regular part of their workforce. This transition will create clear distinctions between organizations that have successfully integrated AI agents and those that have not. Key factors for success will include best practices for AI agent implementation, that is developing and sharing proven methods for deploying and managing AI agents, industry standards and protocols. This means establishing common frameworks to ensure interoperability and consistency across systems. Agent-oriented benchmarks. This is creating metrics to evaluate the performance and impact of AI agents. Continued investment in R&D to support ongoing innovation to stay ahead of technological advancements. And finally, human-agent collaboration models, which includes designing workflows that maximize the strengths of both human and AI agents. In conclusion, we are experiencing a transformative shift in how we live and work. The world stands on the brink of an unprecedented transformation in every field that we know. As we approach 2026, artificial intelligence will evolve beyond simple AI agents and assistants into fully fledged virtual AI employees, reshaping the foundation of organizational operations. This revolution is advancing faster than even the cloud computing era, ushering in a new paradigm of hybrid workforces where humans and AI agents collaborate seamlessly. While the journey will include periods of both hype and skepticism, the underlying value proposition of AI agents remains strong. The key to success lies in measured strategic implementation focused on specific use cases where AI agents can deliver clear business value and a return on investment. Organizations that begin preparing for this transition now will be best positioned to capitalize on the opportunities ahead. There is no doubt that serious challenges and concerns exist, but the potential benefits of well-implemented AI agent systems are unimaginable. The future belongs to those who can navigate this transition effectively and adopt to the change, creating a harmonious balance between human ingenuity and capabilities of artificial intelligent entities whether in software form or embodied in human-like form. Thanks for watching. We hope you liked this content. If you want to learn more about the progress in AI development and its impact on our world, please stay tuned to our channel.